they're going to say rationalize the denominator. Rationalize the denominator. What that means is get rid of the square root from the bottom. That's just fancy talk for basically they don't want us to leave roots in the bottom on any answers. So how do we get rid of that root from the bottom? What can we do to get rid of that root from the bottom in a way that doesn't change the actual value? You know what I mean? We want to make it look different without being different. I always call that plastic surgery. Removing the wrinkles, making it look different, but it's got to be the same value in the end. Same person, just looks different. So, all right, so how do we get rid of that root from the bottom without changing the value? Multiply by what? Yeah, exactly. Yeah, so we just come in here and we just say, well, if you just multiply top, and we're doing top and bottom, that's a fancy 1, isn't it? Root 2 over root 2 is 1. So I'm multiplying by 1. So I'm not changing the value, am I? If you multiply by a fancy 1, right, anything times 1 is the same value it was. I'm doing the same thing top and bottom, so I'm not changing the value. So what's going to happen then? On the top, it's just root 6. No big surprise there. 3 times 2 is 6. What about the bottom? What's root 2, root 2? Plain 2, right? 2 2's in, 1 2 out. Done. What did we do? We got rid of the root from the bottom. There's no more root in the bottom. Does that make sense? We multiply top and bottom to give it a new look. To get rid of the root from the bottom. Hey, can I cancel 2 into 6? No, it's the inside or outside. Right, this guy's outside of jail. The 6 is inside of jail. No interacting. Not without a stand. Whatever, you can't do it. So they're in different worlds, no interacting. If they were both in roots, I would totally cancel. Or if they were both out of roots, I would. But one's in, one's out, different worlds, nothing more, we're done. Good so far? Makes sense? All right, number 2, root of 1/5. So number 2, root of 1. Now, when they put a root over the whole fraction, remember what that means? That just means root of the top, root of the bottom, right? It's just on both. I just like to write it as 2 separate roots for extra clarity. Okay, so go ahead and get rid of the root from the bottom. No root on the bottom. Okay, so what's going to get rid of that root from the bottom? We'll multiply top and bottom by root 5. So what do we got? Root 5 over root 5 in the bottom is? Plain 5, huh? 2 in, 1 out. Everybody good there? 2 5s in the root on the bottom leads to 1 5 out of the root. So we did it. We got rid of the root from the bottom. Can't cancel those. They're different worlds, insider, outsider. Done right there. What did we accomplish? We got rid of the root from the bottom. Good so far? So whatever root you have on the bottom, you just multiply top and bottom by that root. Huh? That gets rid of it. Try number 3. Oh, but it's going to get more tricky. Okay, so let's try that one. So 9 over cube root of 5. So number 3, 9 over cube root of 5. Okay, this is going to be a little more tricky. So what's our goal? Again, get rid of the root from the bottom. Get rid of the root from the bottom. Okay, watch me do it wrong, incorrectly. Don't write this down. You might think, well, just do the same thing. It won't work on this one. So don't write this down. Let me show you it fail so you'll understand. If I just multiply top and bottom by cube root, that's a cube rooter, right? Which means he's a what for 1 deal? He's a 3 for 1. You might say, well, there it is, cube root of 5, plain 5. No, actually, no. What's that? Yeah, that's what you got to do, exactly. Yeah, the reason you got to give it another 5, huh? Because it has to have 3 5s to ship 1 out. It's only the square rooter that does 2 for 1. Are you with me? Let me go back and compare. See See on these guys? See how there was nothing in the hook? Nothing in the hook, nothing in the hook, nothing in the hook. That means they're all two rooters, right? So they're all saying, give me two of whatever, and I'll ship one out. I'm a 2 for 1 deal. So that's why when we gave them 2 2s on the bottom, they said, great, there's one out. A 2, plain 2, shipped out of the root. Same thing here. Got a 5, they're both, there's nothing in the hook, nothing in the hook. 2 for 1 deal. Out comes a 5. 2 5s in, 1 5 out. But that's not going to work when you have a 3 in the hook. He said, no, you got to give me 3 5s. Then I'll ship one out, not just 2. Right? Y'all with me? 2 5s is not enough to ship one out. So, okay, so that won't work, but go ahead and write this down now. Now you know what to do. You got to put another 5, which is 25, yeah. I'm just going to call it 5 5, but you're right. It's 25 if you want to write it that way. Got to do the same thing top and bottom because we can't change the problem, right? Got to keep the same value. We're just making it look different. So you multiply top and bottom by cube root of 5 5. Because that makes a total of 3 5s on the bottom. Now I can ship one out. Does that make sense? So whatever number's in the hook, 3 in the hook, you got to make there be that many 5s inside total to ship one out. So what's coming? So the bottom is just going to be plain 5, no longer in a root. What's the top? 9. Cube root 25. The 9 stays outside. The 5 times 5, 25 stays inside. We're done. What did we do? Got rid of the root from the bottom. Everybody okay with that one? Do you see how it's different when you have a 3 in the hook? You got to make there be 1, 2, 3 all together in the bottom. 2 ship, 1 out. Good. Okay. Number 4 is 7 over root 8x. 7 over root 8x. Okay, so what's in the hook on number 4? Nothing, which means 2. So we're back to a 2 root now. Yeah. Yeah, let me help, guys. Actually, I just realized there's something funny here that I haven't showed you. That 8 can be simplified first, huh? I would do that. First, do that. First, break down that 8, ship stuff out. That 8 is 2 times 2 times 2. Right? Do the 2 for 1 ship out first. And then you'll have a root still in the bottom. Then you need to do the other fix we've been learning. The new fix. But first, do the ship out. I would do that first. Break down that 8. Ship stuff out. So that 8 is 3 2s, right? 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. 2 2s in, 1 2 out, they're gone. So this thing is 7 over 2 root 2x. Good so far? That's just the 2 2s in, 1 2 out thing that we've been doing. How are we doing? Is that making sense? 2 2s in, 1 2 out? Okay. Now, can we leave it that way? No, we can't leave a root in the bottom. So how do we get rid of that root from the bottom? What do we do? We multiply top and bottom by just the root, huh? I don't care about the other stuff. I just want the root to go away. And this one is a 2 in the hook, so I just need 2 of them. How are we doing? Am I losing you? Is this making sense? Let me backtrack. Everybody see what I'm doing? My whole goal is to get rid of the root. So from the beginning, I broke down the 8, 3 2s. 2 in, 1 out. It's 2, 1 2's left in with the x. That's 2 root 2x. And then I can't have a root in the bottom, so you multiply top and bottom by that root. Now, it's not like the last one. It's not like number 3. Number 3 had a 3 in the hook. So I had to make there be 3 5s on the bottom in order to ship 1 out. Not so on number 4. These are just, there's nothing in the hook, which means 2. So I made there be two 2x's. Huh? So out will come a 2x, hitting the 2 that's already out there to be 4x on the bottom. Everybody see that? So on that bottom, I've got 2x's, don't I? And there's nothing in the hook, which makes it a 2-for-1 deal. So 2x's in, 2x out, timesing the other 2 that's already out. That's the only way they get out of jail. There's got to be 2 of them to make the jailbreak, right? To get out of the root. There's got to be 2 of them. 2-for-1 deal. So, what does that give us? The bottom is going to be 4x. What's on the top? 7 times root 2x. We're done. Is that good? It's all well there? Questions on that one? No questions? Okay. Okay. Yeah, little trick, yeah. Okay, so what's our goal? It's to get rid of the root from the bottom. What's in the hook here? 3. So what's a 3 in the hook saying? I'm a 3-for-1 deal. Give me 3 of anything in the root, and I'll ship 1 of those out. Right now, what does he have in the dock bay, in the shipping bay? 9, but 9 is really what? 2 3s. Yeah, I would write that. I would just think of it as 2 3s and 2 x's. That's what he has in there, really, right? He's got 2 3s and 2 x's. Can he ship them out right now, or does he need some more added? He needs some more added. He can't ship until he has 3 of whatever. So he's saying, all right, give me 3, give me another 3, 1 more 3, then I'll have 3 3s and I can ship 1 x. Give me 1 more x, and I'll have 3 x's and I can ship 1 x. So you just give them whatever they need to match their hook number, huh? In this case, 3. To be 3 of whatever, and then they can ship out. So I say, okay. So I'm going to come in here, and so what am I going to multiply top and bottom by?
3x?
Yeah, cube root of 3x, correct. Cube root of 3x. Is that good? So what's going to happen on the bottom? What's going to go down there? What's the denominator going to be?
3x.
Plain 3x, exactly. Does everybody see that? Why? Because we designed it that way, huh? Right? We already had 2 3s, and we put 1 more. So that means 3 3s on the bottom, 1 ships out. We already had 2 x's, we put 1 more. That's why we did it, because we wanted to make an even Steven 3 3s, so 1 would ship out, and 3 x's, so 1 would ship out. Is that good? And then in the top, we've got 7 cube root of 3x, and we're done. What did we do? Got rid of the root from the bottom. Is this making sense? Questions I can answer? All right, so that's number 5. Number 6, 20 over root 5a. 20 over that one shouldn't be too bad. 20 over root 5a. Yep, okay, so try that one. Can I go divide 5 into 20? Why not? Because they're in different worlds. Insider, outsider. 5's in, and there's so many rules, huh? Costco, jail, packages. What's going on here? Yeah, the 5 is in the root. He's in jail. 20's out. No interaction. Now, if that 20 was in, yeah, I would cancel. But different worlds. So don't do that. You can do that. So you just got to get rid of the root from the bottom. What's in the hook here?
2.
Yeah, nothing 2. So you just need to make there be 2 5/8 on the bottom, and then it can chip one out. Let's go ahead and do that. So what am I going to multiply top and bottom by? Yeah, root 5a top and bottom. Is that making sense? So then what do we have? 2 5a's on the bottom, 2 in, 1 out. Good. We made that happen on the bottom on purpose, so there'd be no more root down there. What happens on the top? We'll just crunch them together. Whatever happens, happens. We didn't really care about the top. It's just 20 root 5a. Now, good to there so far? Making sense? So on the bottom, we purposely made it, be 5a by putting 2 5a's in roots, 1 out. Now, can we cancel anything more? Yeah, outsiders with outsiders. Those guys can interact, huh? The 5 and the 20. They're both outsiders. There's no pluses or minuses, so no Costco problems, right? So we can do it. We can, and we must. So 5 goes into 20 4 times, so the answer is 4 root 5a over plane A. There's the final answer. So the outsiders cancel with the outsiders. As long as there's no pluses or minuses. Remember, we're getting to that one in a few minutes. Pluses and minuses would glue things together, make it a package deal, meaning you buy it all or nothing. That's the Costco analogy, right? So keep that in mind. If that had a plus, we'd have more troubles. Got to be more careful. All right. Okay, so number 7 here. Number 7 is 3 over the cube root of 4. Same thing. They want you to get rid of the root from the bottom. So can you get rid of that root from the bottom? What's in there right now? Remember, you want to think about that 4. Break it down. What's in a 4? 2 2's, right? So think that you've got 2 2's right now. I would just make that 2 2's right away. Let me just rewrite that. So that's 3 over cube root of 2 2's, right? A 4 is 2 2's. So we got to get rid of the root. So what's in the hook? 3. So he's saying, give me 3, and I'll ship 1 out. I'm a 3 for 1 shipper. So how many more 2's we got to give it? Just 1 more, huh? Just 1 more. Just multiply cube root 2 over cube root 2. And that'll make there be 3 2's on the bottom, so 1 will come out. Getting the hang of this? We always make there be as many as the hook tells us. The hook is like the director. He's saying, give me 3, and I'll ship 1 out. So if you got 2, you've got to give it 1 more. And you'll ship 1 2 out. Right? Because you got 3 2's down here now. He started with 2, we gave him 1 more. There's 3 2's all together, and he ships 1 out. No more root. On the top, just crunch them together. We don't care about the top. So that's just going to be 3 cube root 2 done. Good. It's getting easier. We're about to come up on a wrinkle here. Try that one. Got to get rid of the root from the bottom. What's in the hook here? 2. So we just got to make there be 2. You can make that 2 separate roots. It's over the whole fraction. So it's top and bottom, right? So you got to make there be 2 5y's on the bottom, right? So we can ship 1 out. So I come in here and I multiply by the square root of. What am I going to multiply by? 5y, huh? Is that making sense? And then what does that mean? Well, in the bottom I've got 2 5y's in, 1 5. What do you do on the top? Just crunch them together, right? We don't care about the top. They're both in roots. This 6x is in, he's an insider, and he's an insider, so they will multiply inside. 5 times 6 is 30. xy, done. Does that make sense what happened in the top? They're all just insiders, so they all just multiply. Can I cancel those y's, top and bottom?
No.
Why not? One's an outsider, one's an insider. Huh? Two different worlds. In jail, out of jail. Same reason I can't go 5 into 30. Two different worlds. Getting the hang of this? This making sense? Getting rid of the roots from the bottom? Okay. Number 10, cube root of, that's the same thing. Let's do 11. Root of 7x over 12. 11. Oops. Root of 7x over 12. Okay. Yeah, try that one. First, I would first break that 12 down. Don't multiply top and bottom by root 12. I mean, you could. I would, but it make your numbers bigger and more difficult. I would first simplify that 12, right? Anytime there's pairs, I do that first because it makes things smaller, simpler. So break down that 12. He's got pairs in it right now. Break down that 12. So 12 is 4 times 3, which is 2 times 2 times 3. What's in the hook here? 2. So he's saying, give me 2 of anything, I'll ship 1 out. So on the bottom, we got 2 2's. So a 2's coming out, the 3's staying in, the 7x on the top has to stay in. Good so far? I'm not done yet. Does that make sense? Just the 2 2's in on the bottom from the 12, sent 1 2 out. The other 3 stayed in. Now you're ready to get rid of the root from the bottom. Now multiply top and bottom. So see how I always do my simplifying first before I multiply top and bottom? It's just easier that way. So now multiply top and bottom. So what are we going to multiply top and bottom by? Yeah, root 3, right? So multiply top and bottom by root 3. And what's that going to do on the bottom? It's going to make 6. Is that okay if I just write 6? Because the 2 root 3's make a plane 3 times a plane 2 is 6. On the top, what do? Just crunch them together. Who cares? Root 21x. They're all just insiders. Good. He's making some good sense. Okay. Jump into 16 with our last 8 minutes. Let's do two of these maybe if we can. So what about this one, based on what you're learning about algebra, should alert you that this one's going to be harder? There's something in there that makes everything hard. The minus. Pluses and minuses. As soon as you see that, you should go, oh no. It's going to be hard. I mean, it's good. I mean, I don't know if you want to go no, but if you should know, it's going to be harder. Things with pluses and minuses are always harder because it glues them together, all that kind of stuff. Okay, watch me do it wrongly. Wrongly? Is that a word? Wrongly? Don't write it down. Just watch it because it's important. You might think, well, just do the same thing. Multiply top and bottom by root 3. It's not true. Won't work. Watch it fail. Top will be 6 root 3. What's in the hook here? 2. So 2 should work. So 1 minus root 3, plane 3. That was illegal what I just did there. And this is minus 2 on the bottom. Got rid of the root. It's great. It's wrong. What did I do wrong in the bottom? This guy would need to distribute to both. You can't just pick your favorite. He'd need to go here too, right? And then there's another root. See how that did not get rid of the root from the bottom? It just made the root jump to the other side. It's not going to get rid of the root. So that isn't going to work. So we got to do something new. What do? When you have a plus or minus on the bottom like that. So let me write that. When you have a root and plus or minus, you must use what's called the conjugate. You heard of that before? It's so important? It's got its own name. It's a conjugate. What does that mean? That means exactly the exact denominator except opposite sign in the middle. It's the exact denominator except opposite sign in the middle. So you go ahead and use exactly what the denominator has, but you put the opposite sign in the middle. You multiply by the whole denominator. Why? Because they're glued together. They're a package. We can't use just the root 3. We've got to use the whole package to make it work. So this is a special deal. How do you know when you're supposed to do this? It's when you got plus or minus. You've got to use the whole thing. Opposite sign in the middle. Now, this will work. What do you mean work? What will it do? It'll get rid of the root from the bottom. Right? That's what we're doing here. So let's carry out on the top. It's just a distribution. 6 times 1 is 6. 6 times root 3 is just 6 root 3. No big deal up there. On the bottom, it's a FOIL. The first goes to both. 1 times 1 is 1 plus 1 root 3. Remember, outsiders stay outside, insiders stay inside. Then minus root 3 goes to both. Minus 1 root 3. And what's minus root 3 times plus root 3? What's negative root 3 times positive? First off, negative times positive is negative. You with me? So far. So negative times positive is negative. Root 3? Plane 3. Did you see that last step? Root 3 is plane 3. Positive times negative is negative. Right? Remember? 2 3's in, 1 3 out. Remember all we talked about the 2 for 1? You good so far? Does that make sense? That FOIL? Right? Root 3. 2 3's in a root. 1 3 either. And positive times negative is negative. Is that good? Now, why are we doing this? We're trying to get rid of the root from the bottom. Well, do you see how it works now? See how these guys cancel? Do you see now why we used the opposite sign? It makes that happen. That's why you use the opposite sign, because that gets rid of the roots from the bottom. You see? No more roots in the bottom. It's a tricky little maneuver. So what does that leave us with? That leaves us with 6 plus 6 root 3 over 1 minus 3, which is 6 plus 6 root 3 over negative 2. Huh. Well, what can we do something with that? Yeah. You can put that negative 2 underneath both of them, huh? You could just make it 2 separate, like negative 2, like that. And then what is 6 divided by negative 2? Negative 3. And 6 divided by negative 2 is negative 3, root 3. There we go. We got rid of the roots from the bottom. It's not even a fraction anymore. There's not even a denominator at all anymore. See how we transformed that thing? So when do you do that? When you see a root and a plus or minus in the denominator. You've got to multiply top and bottom by the denominator exactly opposite sign. So let's just start one of these. How about 17? Minus 4 over root x minus 3. 17 minus 4 over root x minus 3. So try that one. How would you know you need to do the conjugate on this one? Because you got a root and a plus or minus in the bottom. Huh? So those are glued together, aren't they? So you got to multiply top and bottom by exactly the denominator except opposite sign in the middle. Let's multiply top and bottom by root of x plus 3.
So multiply by root x plus 3 over root x plus 3. Is that good? So that minus 4 goes to both. Get minus 4 root x minus 12. Then on the bottom, root x. What's root x times root x? Plain x. Remember? 2 in, 1 out. 2 in, 1 out. Right? What's in the hooks here? Nothing. 2. So 2x, root x is plain x. I mean, you're right. If you think, well, isn't it root of x squared? Yeah. You can write that for a second if you want. Root of x squared, but what is that going to be? 2x's in, 1x out, huh? Does that make sense? See how the rules all agree with each other? Yeah, if you think, well, you told us Mr. to multiply inside or with inside. Right, sure, okay. Root of x squared, but then what is that? Plain x, huh? Because that's 2x's in. So I'm saying it'll be quicker for you just to go, look, 2x is in, 1x out. Root x, plain x. Getting the hang of that? Like root 7, plain 7. Root 11, plain 11. Root x, plain x, right? 2 of the same thing in roots gives you 1 plain out, right? 2 in, 1 out, right? That's the fundamental rule. Okay, so that's plain x. Keep going. Now this goes here. Outsiders stay outside. Insiders stay inside. And then this guy's going to go to both. Minus 3 root x minus 9. And these guys cancel. That's why we use a plus and a minus. No more roots in the bottom, huh? See how that got rid of the roots from the bottom? So what does that give us? Minus 4 root x minus 12 over x minus 9. Now, can we do some more here? Not a thing. Because those are all glued together package deals, right? Plus and minus. They're all stuck together, which means you cancel all of them or none of them. We can't cancel all of them. So we're done as far as we can go. What did we accomplish? We got rid of the root from the bottom. Okay, well.